Okay, as you can see, I changed my mind and I'm cutting this out of solid. That's a piece of that hex bar I've got. So here is the original one, and that was made out of one piece in there, this big piece, and then that piece, 3 pieces, and I got 1/2 mil runout, which for me I suppose isn't mad. I'm going to do it all out of one, so up to the same stage as where I left it off at part 1. So I'm down to 1.5 mil on this diameter. I'm just flattening that off now, getting that face registered. Back to 0, a little bit of cut. Right, I've got all the way in. There you go. The proof is the turntable, or the faceplate, because that's the tightest thread. Tight-ish. It goes up to the register. We're going to put the rotary table mount onto here, but before I do that, I'm just going to have a little explanation of what I've done with this. As soon as this mount was round, any imperfection in this, and it was rocking, this was exaggerated, was dished like that. It's not perfect yet, but it's plenty good enough for this to go on. So anytime I put this on, it was rocking side to side, so I ground it with a grinder, I filed it, I stoned it, I lapped it, I done everything you can think of, and spent about 2 days getting this flat, good enough, so when this went on it wasn't rocking, and now it sits on there quite nice. So I've drilled a couple of holes in so that can be bolted on. And this uses the same bolts and same thread as what we fixed the vise on with. I don't think the hole spacing is quite the same. Perhaps I should have done it the same, but hey ho, never mind. So you can see I've made 2. This one's solid all the way through. It's all made out of one part. And that one is the 3 bits. That piece for the bearing, this middle core, which is a tube for the thread, and then the outer ring for the register. Now the reason why I made another one is that that one was running out 1/2 mil as you rotated the table around. So I thought I'd make another one out of solid and see if I can get it any better. Well, I can tell you now, I didn't. If anything, this one in the solid is slightly worse. It's just over half a mil out, which I'll show you in a little while. But what I will do is I'll swap these over and then I'll compare again, because I've not had that one in for a while. So that has been mounted on, so it is on centre line with the drill. So let's put a faceplate on. And that locks on there nicely. I'll just slacken that off just a tiny bit. And now there is a little bit of flex each side. Take a little bit out of that by doing that up a little bit. So there we go. Right, what I'll do now is I'll put a clock on it, bring it a bit closer, and I'll show you what how it's running out. So let's set that to 0, and then you'll see that's probably about 6/10. Although that one there didn't look so bad. Well, it drops below 40, or above 40 I should say. The side of 60, so well, we're slightly over half a mil out. But the other way, if I put it on the edge, we're about 0.1 of a millimetre out, which I'm happy with. This half a mil equates to, I don't know how much of a degree out of plumb, and even with the flexing on a table you're going to get some of that. Granted, this has got its own flex in it, it's not absolutely rigid, but I'm quite pleased. It will probably do for now for what I want it to do. So I'll just set up on the edge as well, and I'll show you what we've got for run out on concentricity. Right, I hope we're not getting glare off of that too bad. See if I can set that to 0. Near enough. It's at its worst it'll be 0.1, I think. It's probably not even that, which I think that's more the critical measurement. So I'm quite happy with that. It's not the actual faceplate itself. I've run that on the lathe, and running the clock on this face on the lathe, I'm getting plus or minus 200 200ths of a millimetre on here, and on the face about the same, which is normal for my spindle on my lathe. So I'm quite happy with that. What I'll do now is swap back to the original one I made, and we'll have a look at how much better that is or worse. Alright, we've swapped back. That's the solid one we made out of the solid hex bar. Down there out of the way. So we've got the clock back on. And what have we got? Ooh, we've got more run out. We've got a lot of run out side to side on this. Or circular. So maybe that other one is better. You know, I never clocked this one before, so okay, so that's that. What we got on here? That is. I thought this weren't as bad, but it's actually about the same, isn't it? Oh well, so it looks like that spindle is the better one. I shall have to swap them back. Okay. Well, there you go. That's been a fun little project to build, and will be a useful little item that I can use. Gives me, actually before I go, I can tell you off of centre the dimension that gives me. Let's just get a rule. So as far as that'll go that way, that's about it. So off a centre, well, 4.5 inches roughly, 120 mil. It's about right, about 4.5 inches I'd say. So that's going to give me, yeah, 9 inches overall diameter on a drill pattern. Well, thanks for watching. See you next time. Ta-ta for now.